In this lecture, we're going to discuss the geometry of a molecule that has 5 electron densities, and we're going to discuss the first case, which is when you have 5 bonding pairs of electrons. And I have a molecule in mind which is PCl5, in which there are no lone pairs. Phosphorus has 5 electrons and it's bonding all those 5 electrons with chlorine. So PCl5 is only making five bonds with chlorine. There are no other electrons left for phosphorus. There are no lone pairs, only 5 bonding pairs of electrons. So in the three-dimensional geometry, the 5 bonds are going to stay as far away from each other as possible due to repulsion. So I'm going to try and predict the shape of this molecule. What the shape is going to look like is that there's going to be a phosphorus and there's going to be a fan-shaped arrangement of bonds around phosphorus. There's going to be one Cl and another Cl, and so this bond is coming out of the page right now, and there's going to be a dotted line, a dotted bond going into the page. So that's 3 chlorine atoms. And as you can see, I'm basically drawing this fan from sideways. So there's one bond coming towards you and one bond, dotted bond going into the board. So all the angles between these bonds are going to be 120 degrees. But you're left with 2 bonds. Now what would be the position of those 2 bonds? Those 2 bonds, one would be at the top of phosphorus. So that there's going to be one chlorine over there. And remember, it's going to be out of the plane. And one would be going into the downwards. And remember that these 2 bonds are not in the same plane as these 3 Cls. Think of a fan that has that is attached to one chlorine with this with the ceiling. So this bond over here is on top of phosphorus, and this bond over here is at the bottom of phosphorus. So this is how 5 bonds would remain as far away from each other as possible in the three-dimensional space. And the angles that these bonds would be making with each other would be, the fan-shaped arrangement is going to be making 120 degrees. So all these angles would be 120 degrees. Between this chlorine and this chlorine, this angle would be 120 as well. This angle, so the red ones are making an angle of 120 degrees, whereas the green bonds that are coming that are on top of phosphorus and the bottom of phosphorus, they would be making a 90-degree angle with the red bond. So this angle would be 90 degrees. Similarly, this Cl would be making a 90-degree angle with this Cl. So the red bonds, the red chlorines, would be making 90-degree angles with the green chlorines. So just to clarify this diagram a little better, I have this 3-dimensional model of this molecule, and these are the chlorines over here. So let me write down and mention that they are chlorines. Let's put a, so that's Cl. This one is also a chlorine atom. This one is also a chlorine. So there are 5 bonds being made between phosphorus and chlorine. The center one is phosphorus. So based on this 3-dimensional model, that would give you a better visualization of what this molecule would look like. So you can see that there are 3 bonds arranged in a fan-shaped manner, and there are 2 bonds, one on top of phosphorus and one at the bottom of phosphorus. So this is the fan. It's all the bonds are lying in one plane, and these bonds, one is upwards and one is downwards. So they're in a different plane. So hopefully you would be able to better understand what the shape is. The angles between the fans are 120 degrees, and the angles between these bonds and the bonds that are part of this fan-shaped geometry, that's 90 degrees. The last thing that I need to mention is the shape of this molecule, and the shape would be called Trigonal Bi-Pyramidal arrangement. And the reason why it's called a trigonal bipyramidal geometry is that if you connect all the atoms surrounding phosphorus, then it's going to basically end up making so if I connect all the atoms, so it's going to look like 2 pyramids, one on top, and so that's one pyramid, three-sided pyramid, trigonal pyramid, and one at the bottom as well. So if I connect all the outer atoms together, so another pyramid could be formed at the bottom as well. So So these bonds, if I connect them, so it's going to look as if there are two pyramids sitting on top of each other. So it's called trigonal bi-pyramidal. Bi stands for two over here.